Okay, so let's talk about SAT questions. SAT questions, sometimes they will ask you to convert degree to radian, radian to degrees. So make sure you stay on top of the work. When you are not doing the work, that's where I fail you. That's a very simple way I will fail you. I mean, okay, so let's talk about those. Okay, degrees, angle measurement. So angle measurement is there is a degree and radians. Degree and radian. Do you guys know which one's which? Have you guys heard of a radian before? What's radian mean? Something to do with pi, yes. Okay, obviously your geometry teacher didn't tell you that, but it's supposed to taught in geometry. It's supposed to taught in the algebra too. So we're gonna talk about degrees. Degrees is something that you know of. In geometry class, we learn like 30 degree, 45 degrees, and whatever. So we're gonna talk about degree, radian, triangle, and stuff like that, and some major things. So right now we're gonna start with degree. Degree that says 180 degrees is what? A straight line. Good. Most of you guys know that, right? Inside a triangle, how many degrees inside the triangle? 180. Do you guys know that? 180 inside the triangle. There was somebody last year got a 4 on AP calculus, and the following year come back. The person doesn't know how many degrees inside a triangle, but the kid got a 4. The kid worked really hard on calculus, but I never taught him geometry. So I understand that you learn the kid didn't learn geometry with me, and figure out that was he or she thought it was 90 degree inside a triangle. But yeah, it's you have to know 180 degree is inside a triangle. So let me go through all the geometry first, because I think about geometry is kind of important. Degree, radians. A triangle is equal to 180, right? So those angle ABC, plus together equal to 180. Now here's my quick question. Do you guys know how many degree inside a pentagon?
I don't do sides.
Man, your geometry teacher really failed you. How can it be 140? It cannot be less than a triangle.
540?
Huh?
540?
Why?
There's 3 triangles.
Yes, exactly. Inside the triangle, there's gonna be 3. Inside the pentagon, there's 3 triangle. It's actually known as m minus 2 times 180. M minus 2 times 180 for any polygon.
Oh. I remember that.
You remember that?
I did it in 8th grade.
Yeah, you remember in the reason why, if you have pentagon, there's 5 sides, right? Now, this 2 cannot form a triangle because you have this point. This 2 cannot form a triangle, so the only 2 triangles can be created is right here. So total, if you cut up, it's gonna be 3 triangles. So it's always known as m minus 2 times 180. So this is kind of like SAT review in case they ask you how many interior angle there are. So sometimes they give you, let's say, octagon. Then you know octagon. How many sides in octagon? 8. Good. I remember one geometry student told me, he says, on a test, he's like, Mr. Ye, and we were just finished talking about polygon. He's like, Mr. Ye, how many sides is octagon? And I'm like, oh boy. So I asked him, I said, you know, how many legs does an octopus have? And the kid says 6. Okay, so that was very bad. But it was actually 8. So it's m minus 2 times 180. That's how you figure out how many angle inside a polygon. Do you guys remember this now? Sort of? No? Your teacher never tell you? You did? Okay, so that's the stuff that you're supposed to know at 8th grade and geometry class, or 9th grade at geometry class. But that's just basic things that you need to know. One other thing that will be helpful on SAT is this. Let's say A, B, C, and this is D. Is any relationship between A, B, C, D?
Yeah.
What is the relationship? Who says that? C plus D equal to 180. Okay. So can you sum up a one relationship that you're supposed to know in terms of this? Yes. A plus B equal to D. Do you guys know that? It's called exterior angle theorem, which is one of the exterior angle is equal to 2 other interior angle. And the reason being is A plus B plus C equal to 180, right? And what Alex says, C plus D equal to 180. So can we say A plus B plus C equal to C plus D, right? Because they both equal to 180. Can you subtract C on both sides? So A plus B equal to D. So that means 2 interior angle is equal to the third exterior angle. And that's maybe something to helpful for your SAT. I'm just kind of review a little bit about SAT stuff. You need to know? You guys remember this? No? Miranda, no? You have to know. So like I said, I'm going to help you a little bit on SAT. So those are things that you need to know. What else do you need to know? What does the notation mean? That's 2 arrow means what? It's a parallel. It's like train track. Okay. Have you ever seen Mr. Ye parking? He parked like this. Because he's trying to teach you math.
Oh, I thought you were Asian.
Oh yeah, that too. Asian people don't know how to drive. They're really bad. And especially one eye like me. You know how I turn lane is I just turn really slowly because I have a huge blind spot. So like for me, I have one eye, right? This my angle of field vision is about 110 degrees, right? 120 at the most. So I cannot see all this side, right? So if you're on my right side, so don't ever drive on my right side of the road. So what I do if I want to change the lane, I'll just change it really, really slowly until somebody honk at me and I just switch back. So that's my strategy. I figure they're gonna honk at me eventually. So if I change my lane slowly, I don't even have to turn around. So see, big brain. So this angle is congruent to this angle is because why? You don't know why? Okay.
Yeah, that's like opposite.
Okay, you're supposed to know this. If you're from Windy Ridge, it's what? Mr. Madison? You're supposed to know this shit. Mr. Madison actually is a good teacher, from what I heard. Is that true? Okay. So you're supposed to know this. This line is called transverse line. Do you guys remember this? A transverse line is intersect the 2 parallel lines. Okay? Well, the inside is called interior. Outside is called exterior. Do you guys remember this? So inside is called interior. This angle here and this angle is known as alternating. It's because the opposite side of the transverse line. So it's called alternating. Alternate interior angle are congruent. Do you guys remember this? You guys supposed to know this. Okay. Is that okay? Alternative interior angle are congruent. The reason why they are congruent is there is something called correspondence. And the correspondent angle is like this, is in terms of black. So this is called, this angle are congruent because let's say angle 1 and angle 2. So angle 1 equal to angle 2. That there is no proof. So they call it postulate. Postulate, there's no proof. No proof of that. So you cannot prove angle 1 is angle 2, but just always is. If you have a notebook paper, if you draw a straight line, if you measure all this angle, that's going to be congruent. Okay, so that's called correspondent. But because these two angles are cross each other, it's called vertical angle. So it's a vertical angle is congruent, so therefore alternative interior angle are congruent. Okay, so how about angle? If this is angle 1, 2, 3, 4, 5. What's the relationship between angle 4 and 5? Do you guys remember?
It's equal to 180.
Yes. Angle 4 plus angle 5 is equal to 180. It's also known as the same side interior angle. Same side interior angle. Remember, all this question I'm trying to help you on SAT. This is going to be on your SAT. Same side interior angle because 4 plus 5 has to equal to 180 because they are supplement. And so same thing as 3 and 2. 4 and 5 or 3 plus 2 is equal to 180. So it's called same side interior. You have to know that. It's very common question on SAT, just helping you guys review. Now, in the future, when you see this, you think of what we talk about. If you every time you can go always measure how my car phones with the parking lot. Go measure the angle, you will see it. They used to take a picture of my parking and post on a group chat. So this is actual thing happened. So yeah, this is just kind of review. Now let's talk about degree. There's two type of degree. There's two type of angle measurement. The angle measurement, there's a degrees and radians. Now, a lot of people don't understand the difference, including myself. The second or third year, I was teaching pre-calculus. One student asked me, says, "Mr. Ye, what's radian?" And I cannot give him a proper response because the truth is I don't know. And I don't mind to admit that because it's actually kind of funny because my teacher always told me just ignore them. But proper ignorement is actually just lead to ignorance. But if you understand it better, it is actually degree. For me, like if I were to put a human term, I will say this: degree is human made. Because why do people say this is equal to 180 degrees? Why can it be just 200 degrees? So much easier to divide, right? You can divide by 4, it's 50. It's still a nice number. 180 divided by 4 is 45. Why do you want to name it as 180 degrees? It doesn't make sense. Matter of fact, in pre-calculus, you're supposed to know in each degree, you can break to 60 parts. It's called minutes. So 1 degree is equal to 60 minutes. So in one small degree, it can break to 60 parts. And in one of the small parts can break to another 60 part. It's called 60 seconds. So the notation of degree is supposed to be 1 degree is equal to 60 minutes and is equal to 3,600 seconds. So in 1 degree, you can break up to 3,600 parts because 60 times 60 is 3,600. So degree can be even smaller in pre-calc. Okay, but again, Why did people name it 60? Why can it be 100, right? 60 is, it's not a good thing. So 1 degree equal to 60 minutes is equal to 3,600 seconds. So you can break up to 60 parts of each degrees, and each minute can break up 60 parts. Does that make sense or no? Okay, just like time. So that's why they call it minute and second. Jordan, are you paying attention? Okay. Now, radian. You're like, wait, what the hell is radians? And I'm gonna be honest with you. The second year I taught pre-calculus, I don't know what radians is. Can anybody tell me what radian is? It's kind of hard. Radian is not man-made though. Yes.
Is it like how many times? Oh no, I was thinking about what pi is. Like where you can like how many times it would take to like wrap around a circle.
No, but it's a good starting though. Radian is something that most of geometry teachers avoid teaching you because they have no freaking clue, including myself, the second year. Until one day I was looking at something like second year, I was like, oh shit, that's this. This is what it meant. But this is not man-made, it's universal. A radian is universal. Nobody named this. Pay attention why that is, okay? If you have a circle, like if you ever have a circle, and the circle has a central angle, right? So let's just say if I have a circle right here, they're supposed to become a circle. Why are they not becoming a circle? Ah, there you go. So there's a circle, right? Obviously, inside the circle, there is a radius, right? So there is some type of radius here. And we're going to draw that as a red line. And we're going to call it radius. Okay? Now, what you're going to do is take this point and you're going to form exact same length of the radius. So we're going to use this a blue line, represent the same thing. This, we're going to call this arc length is equal to the radius. And that opening, that particular opening is called a radian. Oh, it's 0%, that's why. That opening is called 1 radian. And you might not think that's important. That's actually important because it doesn't matter what kind of circle. That opening, exactly the same thing. It's 1 radian. Doesn't matter how big the circle, how small the circle. That opening of the radius equal to arc length. That opening is roughly 57.3 degrees. Write it down. 1 radian is equal to roughly 57.3 degrees. Why? Why is a 57.3 degrees? You know this. Now this is something you know. Good. You're going somewhere. You're going somewhere. I'm charging my Apple Pencil, so you still can think. Why is a 57.3 degrees? Can anybody answer me that? It does have something to do with pi. Nobody can tell me why it's 57.3 degrees. Okay. This opening here, this is known as 1 radian. So 1 radian equal to 57.3 degrees, roughly. But you guys already know something. You guys know pi radian is equal to 180 degrees. Does that make sense? 1 pi radian is equal to 180 degrees. Why? Because that's 3.14, right? So guess what? Can I divide by pi on both sides? So radian is equal to 180 divided by 3.14. So if you take a calculator, if you take 180 divided by 3.14, that's equal to 57.3 something something something. Roughly it's 57.3 degrees. And I didn't know this the first or second year when I taught pre-calculus, actually first year. Until the second year, I was reading other teachers' notes. I was like, oh, okay, I didn't know that. I was told students to ignore them. And there are reason why I ignore them, because that's 3.14 radian. 3.14 radian is equal to 180 degrees. Because that's that. Okay, so a radian, it doesn't matter how big the circle is, how small the circle is. The bigger the circle, the bigger radius is, right? The arc length is going to be wider, but the opening is actually 57.3 degrees. So it's not man-made, it's universal. It doesn't matter which circle from a different country or different continent or different planet. It's always exactly 57.3 degrees. Are you guys understand? Okay, so universal. Radian is a true measurement that is not man-made. It just works. But we can correlate to man-made degrees is 57.3 degrees. We can correlate that. So radian is better measurement. In my view, is better measurement because it's universal in the world. Okay, so hopefully I didn't confuse you. But let's start with pi radian. We're gonna start another question. Equal to 180 degrees. And this is known as a conversion ratio. You can convert from one to the other, but it's gonna produce two conversion ratio. One is 180 degrees over pi radian, and the other one is pi radian over 180 degrees. Do you guys know this? You're supposed to know in geometry, you're supposed to know in algebra 2. On your SAT, sometimes they ask you, says, hey, convert 72 degrees to radians. You have to be able to convert. So how do you convert them? Let's say if I have 72 degrees, and that says convert to radian. And how do you do that? Well, you're going to do something called dimension analysis. You learn in chemistry. How many of you guys taking chemistry and doing stoichiometry right now? You are? Only one person? Miss Waddell don't teach you nothing? No? She's upping with me, by the way. Yeah. Create new words. Besides Mr. Davis. But that's okay. Davis is okay. Huh? Davis says that too?
Huh?
Davis is talking shit about me again?
Oh, you say Davies or Davis?
Davis. Mr. Davis.
Oh.
Okay, why do I convert one thing to the other thing? Well, I can convert to radian. So what I go is you want a radian to cancel, you want a degree to cancel. So you see that degree. So you want to make sure that if you start with a degree, you want to make sure the degree is on the bottom. And that's a simplification. You can simplify this. And that's equal to 72 over 180 pi radian. Does that make sense? And that's equal to, you can divide by 36 on top and bottom. So it'll be 2 over 5 pi radian. So you can convert 72 degree to 2 pi over 5. Is that okay? How do I convert back? How about say, if I say 2 pi over 5, I want to convert the degrees. How do I do that? So you want to multiply by what? 180 degrees over pi radian, right? So this is radian, because this is radian, because usually you just ignore them, because your teacher told you to ignore them, but it's not why. This pi radian cancel out. 2 over 5 times 180 degrees. That means 180 divided by pi is 2 times 36 degrees. And that's equal to 72 degrees. So you just convert 2 pi over 5 to 72 degree, and 72 degree to equal to 2 pi over 5. You understand? So right now, I want you to convert this. I want you to convert to 20 degrees to radians. 20 degree to radians. And after that, I want you to convert back to degrees. See if it match. So make sure you use dimension analysis. If this is on SAT, that's easy questions. $20 degrees. So can you convert 20 degrees to radian, and can you convert radian to degrees? Samuel, are you done? No? Winston, help out Samuel if Samuel need help. Olivia, are you done? No?
You?
For all scientific notation.
What?
Midway through the year?
Yeah, she just taught us scientific notation today.
That should be a very first day. A chemistry class.
So chemistry.
It should be the first day of a chemistry class to teach scientific notation.
So you do it like
She didn't like me. It's on live stream. Not say anything bad.
Starting at 20 degrees, right? So you're trying to convert it into radian. So you always put the same like unit dividing 180 degrees is 1 radian. So now this unit and when you multiply 20 over 1 over 9 times 5, which is 1 over 9. And so when you do it the other way, start with 1 over 9 and you do it the other way. radians on the bottom, which is the bottom. Which is 180 degrees, right? So
Yeah. Then it becomes
You hate that class? Wait, this Shuri?
didn't teach.
Yeah, she just
You did
gives
no
them
labs.
computer
The
assignments.
computer assignment, you can cheat on all of them.
Yeah. And they don't help.
They don't
She just says go to the helping tab. And the helping
Yeah.
tab doesn't help.
Yeah.
For the one press. One press for kids is just
I say nothing. I'm just gonna smile and say nothing. I personally think, like,
Teaching honors teams.
I personally think that if a teacher don't teach, they should not be teach. They should be, and if they still teaching, they should be locked up in jail.
Probably.
You should not get a paycheck to ruin the kid.
You learn.
Who's that?
All right, so shh. Does anybody still don't understand? Want me to go over it? Raise your hand if you still don't understand. Don't understand? Okay. So if you start with a 20 degree, you want to multiply one of the conversion ratio that has a degrees on the bottom so you can cancel. So you want to multiply this by 180 degrees pi radian. Does that make sense? Huh?
I thought it was 28.
That was 20 degrees. This is degrees. Sorry, it's not connected. It's not connected. It's not connected. Okay, so the degree cancel. So that's equal to 20 over 180 pi radian. So that's equal to 1 over 9 pi radian. Does that make sense? So now if you have a pi over 9 radian, if you want to cancel pi radian, you want a conversion ratio where you have pi radian on the bottom. Does that make sense? And that's 180 degrees, so pi radian cancel out. That'll be 180 degrees divided by 9, so it'll be 20 degrees. So that's how you go back to 20 degrees. Sydney, does that make sense? So if I ask you to convert one to the other one, this is how you convert. Okay. We get off 210 or 220? Okay, we have 10. Nice try, Diego. Now, so I want to tell you that how do you draw an angle, and that's kind of important. If I want to draw an angle, the angle can be, now a long time ago geometry we only had positive angle, but the angle in trigonometry can be negative. Okay, so the way you want to draw something is start with the axis like this. So you have this part is called a x-axis, but in this case it's called initial side. Initial side. And this side, let's say the opening's right here, and that's a 135 degrees. So this opening is called 135 degrees, but it's positive. You can go this way. So you're gonna rotation. You're gonna start from here, and you rotate like this, and that's how you draw 135. Now, by the way, you should know this is 90 degrees. This is 180 degrees. This is 270 degrees, and this is 360 degrees or 0 degrees. So you should understand that 135 is between 90 and 180. Okay? Now, this angle is counterclockwise. So counter clockwise is positive. And if it's clockwise is actually negative. It's actually negative. So you can have a negative angle now. So today, if I want to draw negative 90 degree, what would they look like? Negative 90 degree, what would it look like? You start with the initial side, which is right here, right?
You go down.
You go down. Because clockwise is negative. So here is negative 90 degrees. Counterclockwise is positive, and clockwise is negative. Is that okay? Is it confusing or no? Can it go more than 180 degree? Yes. So that says negative. That says positive. So if I want to draw an angle that says I don't know. That says negative 400 degrees. Okay, or positive 400 degrees. Let's start with positive 400 degrees. If I draw it, I'm gonna start right here. I'm always start with the x-axis from here, and that's gonna be 360, right? And 400 is means 40 degree more, so it's gonna be end up right here. So the way you draw it is gonna be like draw this. And this is going to be 400 degrees. Because it's clockwise, because it's a positive. So this is a 400 degree. Because go one rotation, 360 degree, and do 40 degrees more, it's going to be, like. Okay. Let's talk about coterminal angle. So how do I do coterminal angle? What is coterminal angle? Well, coterminal angle is you facing exact same location. So for example, if you go roller skating, of those of you guys do skateboard, you know what 720 mean, right? What does 720 mean? It goes like this, right? Two rotations, right? If you got 1080, it's 3 rotation, right? Does that make sense? So you can have coterminal angle. So that just says, if today I have 100 degrees, the coterminal angle is gonna face exact same location of 100 degrees. So that means I can take the 100 degree plus 360. So equal to 460. So if you realize 460 is gonna fence exact same direction as 100 degrees. Does that make sense? I'm gonna show you. 100 degrees, a little bit over 90, right? So a little bit over 90. So it's roughly right here. If I were to draw it, this will be 100 degrees. Does that make sense? But I can start from this point. If I draw another circle here, that's gonna be what? If I take this all the way here, this is 460 degrees. Now 460 degrees face the same terminal side as 100 degrees. Does that make sense? So you can add multiple 360. You can say 460 degree is the coterminal angle of 100 degrees. Why? Because the same representation. Now, can you tell me a negative angle represents same as 100 degrees? Negative 260. Does that make sense? I can go this way, right? I can go this way here. Negative 260. The same thing. So negative 260 is also the same representation as 100 degrees. Okay, so that's called coterminal angle. Okay, so basically the formula for coterminal angle is basically theta is equal to the coterminal angle is equal, coterminal angle equal to theta plus n times 360 or plus minus. So you can plus 360 or minus 360. Or it could be this theta plus minus n times 2 pi. Why is 2 pi? 2 pi is a circle. So I can add 2 pi. So if I say I have pi over 9, it could have been 19 pi over 9. It represents same exact location. Right? So if today I say I want to find the coterminal angle of pi over 9, then basically you can say plus 2 pi. You need the same denominator, so you multiply 9 over 9. So that's equal to pi over 9 plus 18 pi over 9. And that's equal to 19 pi over 9. So 19 pi over 9 is same as pi over 9 because they face same exact location. You could have said negative 17 pi over 9 as well. You could say exact same thing. That's called coterminal angle. Is this okay? Not too hard today. Just like let your brain come back. I know you let all the knowledge, all the logarithm, kind of left with the Santa Claus to North Pole. Now if I give you a logarithm test again, you're probably gonna fail that one. And that's why we're gonna ask you to grade the test tomorrow, so that way you can start coming back again. So you still have logarithm inside your head.
What if he failed the first one, so then I never left?
Then I don't know. Then hopefully Santa Claus bring you some knowledge. A box of gift. Knowledge of logarithm. Okay, does this make sense? It's very easy. Coterminal angle is another representation of same angle. Now, negative angle could be going the other side. I'm going to talk about the last one. It's called reference angle. Now, I'm just going to give you a definition first. Reference angle is kind of interesting. Is the terminal side formed with the closest x-axis. So terminal side formed with the closest axis. And you're gonna be like, what the hell is this? Well, let's think about it. Let's say 170 degrees. Where's 170 degrees? Where's that? If I draw it, where would it be at? Right before 180, right? It's gonna be right here, right? Does that make sense? So that's 170 degrees. Now the reference angle is right here. Formed with the closest x-axis. Closest axis. Not the one on the right, but the one on the left because it's closer to there. But it has to be positive. So it has to be positive. So in this case, it's what? No. 10. So the reference angle of 170 is equal to 10 degrees. Because that's a form of the closest x-axis. Let me ask you another question. What will be the reference angle of, that says, I don't know, 212 degrees? What will be the reference angle?
Thanks for another great Titan day. Students, you are now dismissed.
32, good. Because it's gonna be 212 subtract 180. 180 is the closest side. So that'll be always positive. It's gonna be 32 degrees. The reference angle of 212 is 32 degrees. Yes, today you're gonna have homework. Make sure you keep on top of homework. I will not fail you if you keep on doing your homework. But I will fail you if you're not there. Most of you guys that do homework, you miss 1 or 2, I'll let you get by. because I understand everybody have life, everybody have work, everybody have other stuff. I understand that, but at the same time, just keep consistently on your homework. Uh, VPN. Bye every day.
No, I want to show it to you.
Sophia, you missed a ping pong tournament.
Yeah, I literally went to sleep at 6, and then Daniel woke me up. It was like 9 or something. I was like, yeah, if I go.
Why are you gonna sleep by 6 o'clock anyway?
My schedule was so bad. And like, that's when the sun rise.
What the?
It was like the opposite.
I'm history and
Even if I came, I would have like played terrible. Like 2 hours ago, you know. I wouldn't even see where the ball is.
That's good.
Honestly, bio, bro, chumps up.
I agree with that. It's really fun. We're not gonna finish in time.
You sure?
Last year they did.
Yeah, that's true.
that's what I'm anxious about.
They finished
But
last
he's
year.
doing less labs this time, so I don't think.
No, but still.
I think
How late are we?
they didn't finish like
I mean,
2
Landon was telling me they were like kind of going in the same speed as us, and they finished like 2 days before they finished.
Oh, you're lying.
I mean, if you look at, we're only on unit 4, everyone else is on like.
Well,
So.
It's all right. Yeah, you majored in chemistry,